So to use point-to-point mode for your wireless I/O modules, it works in pairs. So point-to-point mode requires only two wireless I/O modules, one to act as the gateway and one to act as the node. You cannot involve more than two wireless I/O modules in a point-to-point mode network. So the first thing that we want to do is that we want to assign one of our wireless I/O nodes to be a gateway. So I have two next to me right here. I'm going to take one, and I'm going to look at the DIB switch that's right by the power terminal, and I'm going to switch that up to gateway. Once I've done that, I'm going to power cycle the module, because it needs to be power cycled in order for the gateway status to take effect. Okay, so now I've done so. And my other wireless I/O module is already set to node, so no need to do anything on that. The next thing we need to do is make sure, so COM port 9 is connected to the wireless I/O module that's set as the gateway, so I'll click on that. So now from here, I've verified that it is indeed in gateway mode. The reason that I can verify this is because if you look at Modbus ID, you'll see that the Modbus ID configuration is grayed out. That's because when set to gateway mode, it locks the wireless I/O module's Modbus ID to 1 automatically. You cannot configure the Modbus ID. It stays at 1. Because the wireless I/O modules are on my bench, they are considerably close together. So I've changed the radio range to short range. However, in a real-world application, you don't want them too close because the signal can be too strong and it can disrupt communications between the two nodes. I verified that my radio network is 0, radio network group is 1, encryption key is signal fire. So now I'm going to go to my wireless I/O module that's configured as the node, which is COM port 5. Radio range is short range. Radio network is 0, radio network group is 1, and the encryption key is signal fire. So the radio settings match, and as you can see, it should be connecting now. And that's what is showing, connected. It's not an ideal signal. That's because I don't have antennas on mine, so the power is very attenuated. The radio signal is very attenuated. But as long as they're connected, it'll do for this application. So let's go back to the gateway module. So we verified that it's connected here as well. So we've connected the two. They are now in point-to-point mode. So how do we use this? Basically, the way that it works is if I insert an analog signal on the input terminal of one module, I should be able to see that same signal on the corresponding output terminal on the other module. So for example, if I am sending 5 volts in through analog input 1 of the gateway module, I should be able to see those 5 volts on analog output 1 of the node module. And this works vice versa as well. So on my bench test, on my lab bench, I have my signal generator. I'm generating 5 volts and I'm connecting that to analog input 1 of my gateway module. As you can see, analog input 1 here is 5 volts or 5,000 millivolts. Now, I should expect to see those 5 volts on analog output 1 of the node module. So if we go out and we connect to the node module, now if you look at analog output 1, it'll show 20,000 microamps. This is because this terminal is set in amps. It does not show you the analog output 1 in millivolts, as we did see for the analog input 1 on the gateway module, that was in millivolts. But if I were to take my multimeter and I were to probe across analog output 1, so I'm connecting to ground and analog output 1 of the node module, I can look at my multimeter and I can see that I am measuring 5 volts on analog output 1 of the node module. So what you also want to do in the very beginning, I didn't mention this in the very beginning, is also make sure to take the hood off the wireless I/O modules and look at the dip switches on the circuit board. Those dip switches switch between volts and amps, or voltage and milliamperage. Depending on what analog signal you want, select the dip switch that it's in either the respective volt or milliamperage desired mode. Otherwise, you're going to look at the toolkit just as you're seeing here, and you're going to be looking at the wrong values. This is in microamps, so it's not showing you what the millivolts signal is, and you wouldn't know that unless something else was telling you that, or unless you took a multimeter and tested yourself. But that is essentially the way that point-to-point mode works.